Hello learners. Today we are going to discuss about inheritance. It is a second pillar of object-oriented programming language. It is a very important concept to set up a communication between two classes. This communication setup will be done by using object of the base class and the derived class. So we will understand the whole concept in a very well way about inheritance. Today outline inheritance in C++, visibility of class members with inheritance concept, type of inheritance, single, multiple, hierarchical, multi-level and hybrid inheritance. One more most important topic we will discuss today, order of constructor call with inheritance concept. So now start inheritance in C++. Inheritance is the capability of one class object to acquire properties and characteristics from another class object. Whenever two classes will have a communication between each other, it will be done by the help of object of two classes. Because only as per the last lectures in class and object we understood already, only the object is having a capability to access the features of the classes and to carry out the details of the class to another part of the program. So this thing explains really the only object having a capability to move around the program. The class whose properties are inherited by other class is called parent, base or superclass. These are the name of the same thing, and the class which inherit properties of other class is called child, derived or subclasses. So here we can understood parent class is only giving. Parent class is only giving. Child class taking. So child is only have taken the properties from the parent class. Parent class never take the properties from the child classes. It is one-way communication. The parent class only giving. Inheritance is a very important concept to make the code reusable. From the parent class, if we have implemented some concept in one class, in the parent class, and we want to keep this concept for further use in another classes, we will not implement the same concept again. We will use the inheritance feature and we carry out our parent class members and access through the derived class object. So this property is called code reusable property. So means we reuse the code of the existing class. We make sure the code in the existing class is carried forward to the derived class. Inheritance makes the code reusable. When programmer inherits an existing class, all its methods and fields become available in the new class, in the derived class. Hence the code is reused. So it means we reuse the parent class members in the derived class. All the members of a class, all the members of the parent class except private are inherited. Private members, we know very well, we already studied about access modifiers. In access modifier, the private access modifier is always keeping the members safe. So private members never be accessible outside the class. That's why we are saying here the same, except the private members we can inherit like public and protected members. Purpose of inheritance. So one purpose we already understood, code reusability. So we reuse the code. Second, method overriding. Then use of virtual keyword. The virtual keyword we will understand in the same session. Virtual keyword is usually used for minimize the duplicacy of the source code. So in C++, virtual function is a member function in the base class that a programmer redefines in a derived class. It is declared using the virtual keyword it tells the compiler to perform dynamic linkage or late binding on the function. So here we use the virtual keyword and we will understand in the further program here. So we are using here the late binding. Basic syntax of inheritance. First is class is a keyword, then the derived class name, subclass name, then the colon, access modifier, public, private or protected. Private members never be accessible, so use the public or protected as well. Superclass, the parent class name. This is the way to implement the inheritance in our source code in C++. While defining the subclass like this, the superclass must be already defined. We should understand whenever we implement an inheritance concept, the superclass already has been defined. So it is an existing class. Only if we have an existing class, then only we can keep the features of this class in the next class. If you do not have a definition of the class, at least it has been declared. Access mode may be public, private or protected as we know before. Access mode is used to specify the mode in which the properties of the superclass will be inherited into the subclasses. So the access modifier is always be helpful how you want to visible the members of the parent class in the derived class. So it will be restricted with the help of the access modifier only. Example of inheritance. Whenever programmer want to use something from an existing class, it means parent class. In a new class, it means derived class. Programmer can use the concept of inheritance. Here is a simple example. We can see here in the graphical representation, there is a animal class and one is dog class. Animal is a parent class, dog is a child class. Class dog inherits properties from its superclass animal. So we will understand here, we create a class animal. Animal is a superclass. Here is a public member, integer type variable legs, initialize the value 4. It means the animal whose legs are 4. Then create a new class dog. Syntax we understand here. First is a class keyword, class, then derived class name or subclass name, dog, colon, access modifier, public, animal is the existing class name or parent class name. So here we understand this particular code we are using for implement inheritance in our program. In this class we have a definition, again the public members, integer type variable tail initialized by value 1. It means we have a derived class dog which has features and characteristics from the animal class. So what are the characteristics it takes from the animal class? The legs are 4. 4 legs and the derived class member tail. Tail 1 means the whole things we can keep together, and we understand here the animal with 4 legs and 1 tail is dog. So existing properties are legs in the animal class and new property we added with it, the dog class, is tail. Now in integer main is a function, is a entry point of our program. Inside the main we can create an object of the derived class. We created an object of the derived class and then we access the members of the parent class and the derived class. D.legs is the parent class member and D.tail is a child class member or derived class member. So here we can say with the help of derived class object we are able to access the member of the parent class and we are able to access the member of the child class. So this can be done only if we are using inheritance concept. If we are using inheritance concept, only we are allowed to access the members of the parent class with the help of object of the child class. So now we receive the output because there is a cout object. Cout object is always showing the output on the screen. So the legs are 4 and then tail is 1. Access modifiers and inheritance. It shows the visibility of the class members. Depending on the access modifier used while inheritance, the availability of class members of the superclass in the subclass changes. It can either be private, protected or public. So we can understand easily public members, the public inheritance. If you are using a access modifier public with the parent class, all the members inside the parent class which are public are accessible easily inside the subclass or derived class. It is the most used inheritance mode. In this, the protected member of the superclass becomes protected of the subclass, public becomes public, and private members are private already. So private member never be accessible. So that's why it should be understood. Private inheritance. In private mode, the protected and public members of the superclass become private members of the derived class. So if you are not writing any access specifier here before the superclass, it means by default it is private. No member of the superclass can be accessed inside the subclass because you have given the visibility private. So private means inaccessible. Protected inheritance. In protected mode, the public and protected members of the superclass becomes protected of the subclass. So in the protected members, private are private, public is also become protected. So protected members are only accessible inside the derived classes. So here the public and protected members of the superclass become protected. So we see in this table the same thing we have shown in this table. You can understand easily the base class, public, private or protected. In the public section, derived class can access the public members, not able to access the private members, and can access the protected members, because protected is showing the visibility inside the inheritance feature. If we are not having an inheritance feature and you just make your members protected, it means this protected, if we are not having an inheritance feature between two classes, this protected become private. So we will understand this. Private, in any case, whatever you are using, public, private or protected, is not inherited. Not inherited in any case, because private members are not accessible outside the class. Protected, public member become protected, so you can inherit in the derived class. But protected members are also you can inherit inside the derived class, but private members are private in any case, so are not able to inherit it. Now types of inheritance. We have different types of inheritance. Number 1, single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, and hybrid inheritance, or also known as virtual inheritance. Single inheritance. It is the simplest form of the inheritance. Here is a class A and the class B. Class A is a superclass, class B is a subclass. So we are receiving the features and characteristics from the class A to the class B. This particular setup of communication is called single inheritance. One derived class inherits from one base class. It's a one base class and one derived class. So this is called single inheritance. Multiple inheritance. Here we can see more than one parent class, and one child class. If we have more than one parent class and one child class, is called multiple inheritance. Don't be confused with the name. This is multiple inheritance. In this type of inheritance, a single derived class may inherit from two or more base classes. So here we have more than one base class, or more than, you can say, two or more than two base classes. This is multiple inheritance. Now hierarchical. In hierarchical inheritance, here is one parent class and having more child. If we have one parent, more child is called hierarchical inheritance. In this type of inheritance, multiple derived classes, more than one derived classes inherit from a single base class. This particular type of inheritance is called hierarchical inheritance. Multi-level inheritance. Here in this structure you can see A, B and C. There is three classes. B is a derived class for A and parent class for C. B is a child class for A and parent class for C. In this type of inheritance, the derived class inherits from a class which in turn inherit from some other class. The superclass for one is a subclass for other. It is a subclass of A and superclass of C. This kind of inheritance is called multi-level inheritance. We have more than one level here, so that's why it is called multi-level inheritance. Now come to the hybrid inheritance or virtual inheritance. Hybrid inheritance is a combination of hierarchical and multi-level inheritance or multiple inheritance. How? First we understand one thing. A is a parent class and has two child. If we are thinking about the first part, A, B, C, this is hierarchical inheritance. And now come to the next. Check here, two classes B, C and third class D. B, C, D makes a multiple inheritance. B, C, D makes a multiple inheritance. Here the class B, class C and class D makes a structure for multiple inheritance, because here we understand B and C are the parent classes for D. So that's why it is showing multiple inheritance. And one more thing, you can see the class A, class B and class D. This particular A, B, D is showing multi-level inheritance. Here again we can say A, C, D. These also A, C, D class is showing multi-level inheritance. So it is a combination of hierarchical inheritance, multiple inheritance and multi-level inheritance. So we understood it. Base class constructors are always called in the derived class constructors. Whenever you call the derived class constructor, the base class constructor always be called there. Whenever a programmer creates a derived class object, first the base class default constructor is executed and then the derived class constructor finishes the execution. Whenever the programmer creates an object for the derived class, always the base class default constructor will be executing first. Then the derived class constructor will be executing. Points to remember here: whether the derived class default constructor is called or parameterized is called, whatever the default constructor is called or parameterized constructor is called, the base class default constructor is always called inside it. Even you are calling the base class constructor or not, it doesn't matter. Whenever you call the base class constructor, whenever you call the derived class constructor, the default constructor or parameterized constructor, base class default constructor always be calling inside it. To call the base class parameterized constructor inside the derived class parameterized constructor, the programmer must mention it explicitly manually while declaring the derived class parameterized constructor. If you want to call the parameterized constructor, default constructor will be calling automatically, but parameterized constructor if you want to call, in this case you need to mention it explicitly. You need to mention it manually. while declaring the derived class parameterized constructor. When you are declaring a parameterized constructor for the derived class, in the same time you will be declare manually constructor to be calling parameterized for the base class. So we will see in the source code now how. Base class default constructor in derived class constructors. A default constructor is present in all the classes. In the below example, a programmer will see when and why base class and derived class constructors are called. So we understand here very well. First, we have a base class or parent class. Inside the parent class, we can see the definition. Integer type variable x is a private member because we are not using any access specifier before int x. So that's why it is a private member. Inside the public, we can see the default constructor of the base class. In this constructor, because it is same name as the class name, we already understood in the constructor and destructors. So if you don't have a knowledge about the constructor destructor, watch my last video, last lecture about constructor and destructors in C++. I will leave the lecture link in the description box of this lecture. So the base default constructor having the definition cout base default constructor, only this statement we have written here with the cout object. Now close the constructor definition and close the class. After that we will come to the derived class definition, and now you can see we are using here the colon and with access mode public and the parent class. So we are using inheritance concept here. It is pretty clear. So in this base class we have a base class constructor. Now we will understand. Inside the derived class definition we have integer type variable y. It's a private variable, and public is a section here. Inside public we have a default constructor for the derived class. So this is a derived, this is the name of the method, and this method having the same name of the class name. So it is a constructor. It is a special method or special member function. So here the derived default constructor, inside the definition we have written here derived default constructor with the cout object. Close the definition of the constructor in the derived class. Now we have one more constructor here for the derived class, is a parameterized constructor. So inside the parameterized constructor we should pass the parameter. We pass the parameter integer type variable I. Cout derived parameterized constructor inside the definition of the derived constructor. Now close the class. So inside the derived class we have two constructors. One is derived default constructor, one is derived parameterized constructor, and one data member private. After that we come to the main body. Inside the main body we will see first we create an object for the base class. We create object for the base class. If we create object for the base class, which constructor will be calling? Only the base constructor will be calling, because we just create an object for the base class. It will not interact to the derived classes. We know very well the derived class object can interact with the base class, but base class never be taking any feature from the derived class, so it will not interact with the derived class. Even you are using here inheritance property, but it doesn't mean it will be directly access the base class members. It will be directly access the base class members. So that's why it is only showing the result from the base class. So whenever you create an object of the class, constructor invoked automatically by the compiler. It means your constructor is invoked by the compiler automatically, and you will get the result base default constructor. So that's why you are receiving the output here base default constructor. Now come back again to the main function. Inside the main body we are seeing the second object for the derived class, derived D1. Derived D1. D1 is a object for the derived class, and we are not passing any value with the object. It means we are calling the default constructor. In this case, it will automatically jump to the derived class, and we know very well whenever we create an object for the derived class, first it calls the constructor of the base class. So base class default constructor should be called automatically while you are creating an object for the derived class. So first it will execute the constructor of the base class, then execute the constructor of the derived class. So in this case, we receive the result here, base default constructor and then derived default constructor. So we understood here, we create object for the derived class, but it should access base class constructor first, then the derived class constructor. We already written on the last slide about it, so we understood. Now come to the back to the main function, and we see here is a parameterized. We have created an object D2 for the derived class and passing the value, it will automatically call the parameterized constructor in this case. So before parameterized constructor, also it will execute the default constructor of the base class. So again, we receive the value here, base default constructor, and then we receive the value for the derived class parameterized constructor. So in all the cases, we understand whatever we create object for the base class, we executed the base class constructor. Whenever we created an object for the derived class, the default base constructor is called first, then the derived class default constructor is called. And whenever you create an object for the parameterized the constructor in the derived class, so here again we access first the base class constructor, default base class constructor, then the parameterized constructor of the derived class. So it is pretty clear about the default constructor always be calling first from the base class. In this example, we both the object creation of the derived class and the base class default constructor is called. Now, base class parameterized constructor in derived class constructor. It is a explicitly mentioned whenever you need to call the base class parameterized constructor, whenever programmer needs to call the base class parameterized constructor, it should be explicitly mentioned. So how we will be seeing here, the programmer can explicitly mention calling the base class parameterized constructor when the derived class parameterized constructor is called. First we see the definition of the class base is a base class. Inside the base class we have a private member X. Public is a section. Inside the public section we have a parameterized base class constructor. We pass here the value as an argument int I. Then we initialize the data member of the class, the private member X, and initialize by the value I whatever we pass, and see out base parameterized constructor. We have written, just we want to see the control of our program, that's why. And now close the definition of the base parameterized constructor, close the class. Come to the derived definition, derived class definition. Here we are using inheritance with the public access mode to the base class. Now inside the derived class we have a private member Y. Public, inside the public section we have a parameterized constructor of the derived class. Now we will understand what we said here in the definition. Whenever we need to execute the parameterized constructor of the base class, we should write this source code explicitly. We should write this source code explicitly. So derived, pass the variable integer type j, then colon base class parameterized constructor. We should write here manually, explicitly, base j. This is a parameterized constructor. Whenever we are calling the constructor for the derived class, if we need the parameterized constructor of the base class, we should mention here in the source code like this. Now inside the definition of the derived class, we put the definition here, and after that close the class. And now you can see inside the main body, we created an object for the derived class. We pass the value here 10, whenever you pass the value here, this value directly we initialize to the base class and the derived class. So it means whenever you call the derived class constructor, first your control will pass to the base class constructor. But if you are not writing here, it will call the default constructor of the base class, not calling the parameterized. If you want to call the parameterized, you should write the source code inside the derived class manually for the parameterized constructor. So it will directly first execute the base class parameterized constructor, then execute the derived class parameterized constructor. So we will understand here base parameterized constructor and then it will execute the derived parameterized constructor. This is the way of executing the base class parameterized constructor in the derived class constructor. Now, why is the base class constructor called inside the derived class? We should understand here, constructors have a remarkable job of initializing object correctly. We know very well constructor used to initialize the data members of the class, initialize the object of the class. A derived class constructor has access only to its class members. So derived class constructor has only access to its class members, means derived class members. However, a derived class object also has inherited property of the base class, and we know very well due to the inheritance we have the derived class object also having a feature of inheriting of the base class members. Only the base class constructor can properly initialize the base class members, and in this regard we know very well only the base class constructor is helpful to initialize the base class members, because we know very well constructor is always used to initialize the data members of the same class. So derived class is only allowed to initialize the derived class members. So base class also needs to initialize the data members of the class. In this regard, base class constructor is helpful to initialize the data members of the class. That's why we have a framework with the feature to be called always the base class default constructor in any case to initialize the data members of the base class. So we can understand here, thus all the constructors are called, even the base class object would not be well constructed. If you are not constructing any base class object, even your constructor will be called. We understood already. Constructor call in multiple inheritance in C++. So we can say how to write a multiple inheritance. It is almost the same. All the base class constructors are called inside the derived class constructor in the same order in which they inherited. In the same order in which they inherited, it will be called as the mention of inheritance. So here the class A inherit class B public modifier class B, comma public modifier class C. So here is two classes B and C. So what is the meaning of it? A is a derived class, B and C are the parent classes. So here we are using multiple inheritance. B is a parent class, C is also a parent class for class A. In this case, you should remember, first it will execute the constructor for the class B. We will read this from left to right. So here B class constructor will be executing first, then the C class constructor will be executing, then the class A constructor will be executing. It depends on the position of B and C. A class constructor is a derived class constructor. It will be always executing at the last. But the confusion between the B and C. So if your class B is near to the colon, so class B constructor will be executing first, and then the other classes constructor will be executing as per the nearest of the column of the inheritance. In this case, our first class B constructor will be executed, then the class C constructor, and then the class A constructor will be executing. So don't be confused in this regard how the constructor call in multiple inheritance in C++. Hybrid inheritance with virtual class in C++. In multiple inheritance, the derived class inherits from more than one base class. Hence, in multiple inheritance, there are a lot of chances of ambiguity. Ambiguity means duplicacy. So how we get the duplicacy chances with the multiple inheritance? Number one, the class A. Inside the class A, we have one method show, one function show. This is the show function having a return type void and the name show with no parameters. Now the class B. Class B is a child class for A, and then the class C. The class C is also a child class for A. It means A is a parent class, B and C are the child classes. So this is hierarchical inheritance. This inheritance is called hierarchical. If we are talking about this is called hierarchical inheritance. Now come to the next. Here is a class D. For class D, we have a parent B and C. Now we have two parents for class D. It means this is a multiple inheritance. This particular inheritance is called multiple because we have more than one parent. If we have more than one parent, is multiple inheritance. Now we can understand here what is the logic here. The logic is B can access the features and characteristics from the class A because it is having an inheritance property with the class A. C is also having an inheritance property for class A, and class A features also be accessible with the class C. So class C and class B both have the show method to be executing. Now in the class D, we are accessing the members from the class B and the class C. Class B and C having a members from the class A. So class B having a show method and class C having a show method. Both are having a show method. It is really very confusing to the compiler which show method will be executing. It makes the ambiguity. Lot of chances of ambiguity here. So now we understand. We create object inside the main for the derived class. So derived class is D. D object, obj is the name of the object for the derived class, and this member will access the feature from the B, will access the feature from the C. C can access the feature from the A. B can access the feature from the A. So obj.show. Now which show method will be called here? This is the calling part of the program. So now we see in this case both class B and C inherits function show from the class A. B and C both are inheriting the function from the class A. Hence D class has two inherited copies. So inside the D class we have a copy of the show from the class B and the class C. In the main function, when the programmer call function show, then ambiguity arises. Duplicacy will arise because the compiler does not know which show function to call. Now compiler is really confused which show function should be calling this time. Hence we use virtual keyword. In this regard, we use virtual keyword while inheriting the class. We see in the next slide. So understand here the virtual keyword we use to minimize the ambiguity of our calling in the same function of the program. Now by adding a virtual keyword, the programmer tells the compiler for calling any one out of the two show functions. Now we use how virtual here. Class B virtual public A, class C virtual public A. So it decides only one time the show function should be calling. We put the virtual keyword here before the A class for inheriting with the derived class B and with the derived class C. Now the D class having a features from the class B and class C, the multiple inheritance. So here it always calling only the one show function from the class A. In the last program, just change this and this confusion will be over. Hybrid inheritance and constructor call. As the programmer all know that whatever a derived class object is instantiated, whenever instantiate a derived class object, the base class constructor is always called. But in the case of hybrid inheritance, as discussed in above, if the programmer creates an instance of the class D, then the following constructors will be called. So what is the way? Before class D constructor, constructors of its superclasses will be called. What is the constructor of the superclasses here? B and C are the superclasses for D. So hence constructor of class B, class C and class A will be called. So constructor of class B, constructor of class B, class C and the class A. Second point, when constructors of the class B and class C are called, it will again make a call to the superclass constructor. B, C, A will be called first time, and when our control passes to the class B, again the A constructor will call. When the passes to C, again the C constructor will call A. So when constructors of the class B and C are called, it will again make a call to the superclass A constructor. In all the cases, the A constructor will be calling. It will result in multiple calls to the constructor of the class A. It means the calling to the constructor of class A multiple times, which is undesirable because it lowers our performance of the product. So that's why programmer doesn't want to call the same constructor again and again. As there is a single instance of a virtual base class shared by multiple classes that inherit from it, the constructor of the base class is only called once by the constructor of the concrete class, which in this case is class D. Class D is our concrete class because we are creating an object of this class. So whenever you create an object of this class and using a virtual keyword, in this case the constructor of the base class is only called once, then the constructor of the base class will be calling by one time. All such calls will be ignored, then other calls will be ignored if there is any call for initializing the constructor of the class A in class B or class A in class C while creating an object of class D. Whenever create an object for the class D, so only one time the class A constructor will be calling in the class B or in the class C by using a virtual base class. So this is the full concept of inheritance, how the inheritance and constructor calling to be managing inside the program. Thank you so much. Do the comments, share and subscribe my channel. If you have any question, you can ask in the comment section. I will be happy to answer you.